Hey everyone, and welcome back. Almost every single piece of amazing AI that you use, from your chatbot to an image generator, it all traces back to one single powerful idea that popped up back in 2017. And today, we're going to pull back the curtain on that one big idea. Think about it. You're interacting with this technology all day long, probably without even noticing. But what is it? What's that one core concept that's driving everything from your phone's autocorrect to the most advanced scientific breakthroughs?
All right, let's dive right in. To really get a sense of just how big this is, we've got to start with what people are calling the transformer revolution.
So, when you think AI, your mind probably jumps to chatbots or maybe personal assistants, right? And yeah, you're not wrong. But that same underlying tech is doing so much more. It's writing entire articles, translating languages on the fly, generating computer code, and even creating incredible images from scratch. And here's the real kicker, just to show you how far this reaches. Look at that last point. It's even shaking up super specialized fields like patent law, where lawyers now need to understand this stuff just to do their jobs. So what's the name of this thing? It's called the Transformer. And its arrival back in 2017, well, it was nothing short of a big bang moment for the AI we know today, pretty much leaving everything that came before it in the dust. Before 2017, the top AI models, which were called RNNs, had this huge problem. Imagine trying to read a whole book, but you can only look at it through a tiny straw, one single word at a time. It was incredibly hard for the AI to remember the beginning of a long sentence by the time it got to the end. But Transformers? Totally different ballgame. They process all the words at the same time, in parallel. It's like going from a straw to a bird's eye view of the entire page. This whole revolution kicked off with a research paper from Google, and the title was so simple, almost poetic, and now it's famous. Attention is all you need. And this, right here, this is it. This diagram, straight from that 2017 paper, is the blueprint for the Transformer. Pretty much every single large language model you've ever heard of, GPT, Llama, Gemini, you name it, is built on this fundamental design. It's the foundation for everything. Okay, so we keep using this word attention. What does it actually mean? Let's break down the secret sauce that makes this whole thing work, the thing that gives it that deep understanding of context. When you type a prompt into a chatbot, here's what's happening under the hood super fast. First, your sentence gets chopped up into little pieces called tokens. Then each of those little tokens gets turned into a string of numbers, a vector, that represents what it means. But step 3, this is where the magic really happens. The transformer calculates how much attention each token should pay to every other token in the sentence. That's what creates this incredibly rich, context-aware understanding. This slide is the perfect way to see it in action. Take the sentence, "The animal didn't cross the street because it was too tired." To figure out what it means, the model learns to pay a whole lot of attention back to the word animal. But let's say the sentence ended with, "because it was too wide." Well, then the model would learn to pay attention to street instead. It's learning these relationships on the fly, no matter how far apart the words are. It's brilliant. So, simply put, the attention mechanism is just a way for the model to weigh the importance of all the other words in a sentence to figure out the true meaning of any single word. It creates these invisible threads that link ideas together across the entire text. Once this paper dropped, things went absolutely wild. It wasn't just a small step forward. It sparked a Cambrian explosion of new AI. The timeline of what happened next is just incredible. You can just see the acceleration right here. Just 1 year after the paper, boom, Google drops BERT. Then OpenAI jumps in with its GPT series, with each model getting exponentially more powerful. Then 2022, ChatGPT lands, and suddenly everybody is using this stuff. And the very next year, Meta open sources its Llama model, and the entire field just shifts into overdrive. It's a total whirlwind of innovation, all built on that one original blueprint from 2017. But here's a key question. A raw AI model is great at predicting the next word, but that doesn't make it, well, helpful. So how do you train it to be a useful assistant? Through this really clever process called reinforcement learning from human feedback, or RLHF. Think of it like this. Humans act as teachers. We grade the AI's responses, telling it, this one's good, or nope, this one's bad. And with all that feedback, the model gets fine-tuned. It learns to be helpful and harmless, turning all that raw power into a genuinely useful tool. All right, so where is all this headed? Well, the next giant leap is moving beyond just understanding language to understanding the actual physical world. And this is where things get, frankly, a little mind-blowing. Researchers are now training AI not just on text, but on massive amounts of video. So you have models like Meta's VJPay-2, and they're starting to build an intuitive grasp of physics, cause and effect, just by passively watching countless hours of unlabeled videos. And the results are staggering. Look at this. When asked to plan a robotic action, VJPay-2 can figure out the steps in just 16 seconds. A competing model takes a full 4 minutes to do the same task. That's a massive leap in efficiency, and it shows just how well these new world models are beginning to understand cause and effect. And that brings us to our final thought. The transformer started by learning the relationships between words. Now it's learning the relationships between objects and actions in the physical world. So the crucial question is this: if AI learns to understand our world just by watching it, what will it learn to do next?